Today I am going to solve a problem. The problem comes under the category of polytropic process. The problem is a fluid at a pressure of 300 kPa and with a specific volume of 0.18 kg per meter cube. It is contained in a piston cylinder arrangement. Expands reversibly to a pressure of 60 kPa. According to the law of P V square is equal to constant, where P is in kilopascal, pressure in kilopascal, V is specific volume meter cube per kg. Calculate the amount of work done by the fluid in terms of kilojoules per kg. Clear? Right. What are the given data? P1 is given. P1 is given, that is 300 kilopascal. 300 kilopascal. Initial pressure. Final initial volume V1 is equal to 0.18 meter cube per kg. Meter cube per kg. Final pressure P2 is given, that is 60 kilopascal. That is 60 kilopascal. The polytropic process law is given, that is PV square is equal to constant. PV square is constant. Okay? So before entering to solve the problem, first let us find out the value of constant C. What is the value of C? From this equation we can write like this: P1 V1 square is equal to constant. P1 V1 square is equal to constant. P1 value is equal to 300 kilopascal. V1 value is given into 0.18 meter cube per kg the square whole square. This is constant C value. Okay, so therefore C is equal to 9.720 kilopascal into meter cube per kg the square. This is constant value. Using this constant value, it is possible to find out the value of V2. Find out the value of final volume. So from this equation I can write like this: P2 V2 square is equal to constant. Okay, this equation gives V2 square is equal to C divided by P2. So V2 square is equal to constant value C, 9.720 kilopascal into meter cube per kg the square, or divided by P2 value. Just now P2 value is given 60 kilopascal. 60 kilopascal. Kilopascal gets cancelled. After taking root of this value, this square meter per square value gets cancelled. The answer becomes V2 is equal to 0.408 meter cube per kg. Now entire information is ready. C is ready. Final volume V2 is ready. Now I am going to solve the problem in order to estimate the amount of work done by the fluid. This expansion process. According to first law of thermodynamics, it states that dW is equal to P into dV. You can write like this: W is equal to integral P dV. Limit V1 to V2. Limit tends to V1 to V2. From the law, that means PV square is equal to C. It will give the value of P. So P is equal to C divided by V square. P is equal to C divided by V square. So W is equal to constant integral 1 by V square into dV. Limit tends to V1 to V2. This equation can be written like this: V power minus 2 integral V1 to V2. This is value. W is equal to, after integration, C into, that means V minus 2 plus 1 divided by minus 2 plus 1. X to the power n into dx is equal to x to the power n plus 1 divided by n plus 1. Limit tends to V1 to V2. So this equation C into minus C into 1 by V into V1 to V2. Okay. So W is equal to minus C 1 by V2 1 by V1. So to avoid this minus value, I can write like this: C into 1 by V1 divided by 1 by V2. The minus sign gets exchanged. Okay, amount of work done by the fluid W. Now substitute all the values. C is equal to 9.720 kilopascal meter cube per kg the square, into 1 divided by 0.18 minus 1 divided by 0.408. The unit for this specific value, inverse value 1 divided by meter cube per kg. Meter cube per kg. This term, the square term gets cancelled. The remaining answer becomes 29,029.821 kilopascal into meter cube per kg. The answer in terms of kilojoules per kg. Hence, I am going to convert kilopascal into pascal. That means 29,821 pascal into meter cube per kg. To avoid pascal, 1 pascal is equal to 1 Newton per meter square. Pascal gets cancelled. This meter square and cube term gets cancelled. The remaining thing is W is equal to 29,821 Newton meter divided by kg per kg. This Newton meter term is joules. So joules per kg. 29,821 joules per kg. I am made of kilojoules. Means 29.821 kilojoules per kg. 29.821 kilojoules per kg. This is the answer. Amount of work done by the fluid during its expansion process. Okay, thank you.